Okay, let's dive right into this explainer. Today, we are going to completely decode the fundamentals of motion graphs, specifically tailored for the Cambridge IGCSE Physics 0625 syllabus. But listen, we aren't going to just stare at lines on a grid and memorize what they mean like a textbook. That doesn't work. Instead, we're using a concept-first approach. We're going to build your understanding from absolute first principles. I want you to imagine two typical physics students taking this exact exam. Let's call them Alex and Sam. Alex overloads every answer with raw physics facts, just dumping information without any real analysis. Then there's Sam. Sam rushes, panics, and completely misses the command word requirements of the question. They both lose massive marks. Our goal today is to simplify the complex so you don't make those mistakes. We are going to prove that one powerful, deeply understood idea is worth 1,000 memorized words. By the time we're done, no matter what kind of crazy complex graph the examiner throws at you, you will instantly know exactly how to break it down.
To avoid relying on memorized wording, which is exactly what trips up students like Alex, a strong start requires us to ask a really crucial question. What physical effect, measurement, or prediction actually depends on understanding more motion graphs? Like seriously, why do we care? If we don't know why we're looking at a graph, we're just doing a math exercise, not physics. By asking this question first, we guarantee that we aren't just reciting definitions. We are forcing our brains to connect the formal, sometimes intimidating language of physics to an actual, real-world necessity. This approach is an absolute game changer. It makes you far less dependent on rote memory and significantly more capable of reasoning your way through completely unfamiliar, high-pressure exam scenarios.
Section 1. The core system, moving from everyday language to physics vocabulary. Now, when you face a complex motion graph, I do not want you to panic like Sam does. Just breathe and walk through these 4 linked steps. Think of this as your PEEL framework, point, evidence, explanation, link, but weaponized specifically for Cambridge physics. Step 1, identify what quantity or phenomenon you're actually looking at. What's on the axes? Step 2, state the relationship involved. This is where you might introduce a symbolic formula or a specific definition, but only once you clearly know what you are dealing with. Step 3, explain the underlying physics. Why is it happening? And step 4, connected to a real observation, an experiment, or a physical device. If you followed this exact sequence, you show examiners both deep understanding and practical application. It moves you smoothly from a concrete, everyday understanding straight into high-level physics analysis. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's keep building this system.
Section 2. Decoding graph physics, connecting visuals to tangible physical actions.
We absolutely have to remember that a slope isn't just a slanted line on a piece of paper. We must stress what it means physically for an object in motion. When you look at the steepness of a graph line, you are looking at a very specific rate of change. If it's a distance-time graph, that slope is physically representing velocity, how fast a car is actually driving down the highway. If it's a speed-time graph, that slope represents the raw acceleration. It's the actual physical push you feel in the back of your seat when a car slams on the gas. You have to visualize that. It is a direct visualization of cause and effect. Don't just see a line. Feel the physics happening.
Similarly, the area under that slope translates into a tangible measurement. It demands that we focus on physical realities over isolated math facts. Think about it. The space trapped between the graph line and the bottom axis isn't just empty room that you color in. In a speed-time graph, calculating that physical area gives you the exact literal distance an object has traveled. It takes a visual concept that seems purely theoretical and grounds it entirely in a calculable physical reality. If you can explain that to an examiner, you are guaranteeing yourself top marks.
And this brings us to direction and shape. The visual curves or angles give us the ultimate cause and effect, explaining exactly how invisible forces are impacting the object. A sudden sharp angle? That means an abrupt, aggressive change in physical behavior, like a collision. A gentle sweeping curve? That indicates a changing force. Imagine air resistance building up against a falling object, pushing back harder and harder until it finally reaches terminal velocity and the line flattens out. Whether we are dealing with forces, particles, or waves, we must always insist on tracing these shapes back to their physical cause and effect rather than treating them as abstract doodles.
Section 3. Real-world applications, where motion graphs matter. Stop scrolling. Subscribe to our YouTube channel Ace the Exams.
@acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's look at this list. You should always be able to name at least one real situation from these fields and explain why the physics helps us predict or improve outcomes. This micro-topic stretches way beyond the walls of your classroom. Motion graphs are the bedrock of designing safer transport systems, optimizing complex energy grids, and even plotting the trajectories of satellites in astronomy. When you are learning this material, I want you to constantly ask yourself, where is this used? If you can connect the graph of a rapidly decelerating object to the microsecond accurate deployment of a car's airbag to save a life, you aren't just memorizing physics anymore, you are wielding it like a pro.
Section 4. Avoiding exam traps, safeguarding your marks.
Let's contrast the safest method for structuring your answer against the most dangerous exam traps. This is where we see the difference between top-tier students and students like Alex and Sam. The safest method, your physics success blueprint, is a complete chain. Give the definition, state the relationship, explain the physics, and provide the application. On the flip side, the most common weakness, this is classic Sam behavior, is rushing and dropping a perfectly correct formula onto the page without actually explaining what the variables mean physically. The examiner will just give you a 0. Another massive trap, which is what Alex does, is quoting a process or giving a real-world example without showing exactly why it follows from the physics. You must keep every single answer tightly connected to clear cause and effect reasoning. Don't just write v = d/t and walk away. Explain the velocity is the rate of change of distance and link it back to the physical movement of the object. That is how you turn red pen marks into green check marks.
Section 5. Quick recall, the 4 essential prompts.
As we wrap up this explainer, we need to ensure your knowledge is rock solid. Think of this as your ultimate cheat sheet. If you can answer these 4 revision prompts aloud right now, your grasp of the topic is usually secure enough to tackle any short answer or structured question on the 0625 syllabus. First, what is the core idea? Second, when we look at the graph, what is actually changing physically in the real world? Third, what specific quantity, formula, or visual graph feature illustrates that change? And finally, fourth, where is it used in everyday life or advanced engineering? Test yourself with these prompts constantly. Listen, students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
So, I leave you with this final challenge. Can you build that causal chain entirely from first principles right now? The next time you see a curve on a graph, don't just see a line. Ask yourself what invisible force is painting that picture. Keep questioning the physical reality and you won't just pass the exam, you'll master the physics. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.